Hey pre-calc students, welcome to today's lesson on 8.4 Notes Day 3. Today we're going to be focusing on writing equations of parabolas. If you remember, a couple of things that are really important when graphing parabolas is knowing where the vertex is and also the value of p. So the first thing that I want to do is identify the vertex for number 1, which is 4, 6. Right, it goes 1, 2, 3, 4, 2, 3, 4, 5, 6. A couple other things that are important, right? I told you that P is important. P is the distance from the vertex to the directrix, which is that dashed line. And it's also the distance between the vertex to the focus. So in this case, P is 2. Some other things that are important is the fact that this parabola opens down, which means that the major axis, excuse my handwriting, it's a little bit messy. The major axis is the y-axis, because the y-axis goes up and down, right? All right, now as we start to kind of set up the equation, since it opens the way the y-axis goes, which is up and down, your linear term has to be the y, that's your major axis. So I'm going to use the y value of the vertex, just take the opposite of it. I'm going to set it equal to, this is where you usually have 1 over 4p. So think about it, it's 1 over 4p, right? Well, we said p is 2. So 4 times p, or 4 times 2, would be 8. Okay? Remember that in here, in front of the parentheses is always, in front of your quadratic term is always 1 over 4p, or negative 1 over 4p. So because this one opens down, you want to make sure that it is negative. And again, I just plugged in the value of 2 into 1 over 4p. And again, I used a negative because it opens down. Okay. And then my quadratic term is going to be x. That's my minor axis. And don't forget, it's quadratic, so put the squared. For number 2, the parabola opens left. And I'm going to go ahead and identify the same important information that I did in the previous problem. So the vertex is -2, -4. The value of p is the distance between the vertex and the focus. The focus is the little red dot. It's also the same distance between the vertex and the directrix, which is the dashed line. Okay, so because this opens left and the x-axis goes left and right, that means that your major axis, oopsies, your major axis is the x-axis. Okay, so as I start to write my equation, the major axis is the one that has to be linear, so it's going to be x to the first power, and then change the sign for the x value equals. Now notice it opens left, so then that means that this fraction is going to be negative, or that value is going to be negative. And that value is always 1 over 4p. So since p is 3, I forgot to write that over here, p is 3, then you're essentially multiplying 4 times 3, which gives you 12. And it's negative because it opens left. If it had opened to the right, then we would want a positive 1/12. And then you're going to want y plus 4 quantity squared. Remember, your major axis belongs to the variable to the first power, and your minor axis is the quadratic. Okay, so now we're going to kind of take a look at how you can complete the square to write the equations in standard form for parabolas. So the main thing you have to remember is you want the quadratic terms on one side and the linear terms on the other. Um, and essentially all the y's on one side and all the x's on the other. So you still can move the constant term to the other side. So let me just zoom in here. So you still want to move the constant term to the other side, but also you want to move the x's, which are linear. In this case, all the linear terms with the constants on one side. So I'm actually also going to move the 2x to the other side. So notice that the constant term and the linear term for x, I'm moving to the other side. That leaves me with the quadratic y plus 8y equals, and I'm just going to put these in order, minus 2x minus 24, or negative 2x minus 24. So one of the things that I said on here as a hint, your linear binomial must have a coefficient and exponent of 1. Okay, so already thinking about that, this guy, I'm not going to be able to leave it like that because my coefficient and my exponent should be 1. So the good news is my exponent is already 1, but the bad news is my coefficient is not a 1. So I'll show you how to do that. But this guy has to be written with parentheses and a squared, so we need to complete the square. So I'm going to take half of 8 and square it. And I'm going to keep the balance. So that's, oh, you always got to make sure you keep the balance. And then I'm going to simplify. So this factors to y plus and whatever half of this number is. So it's a positive 8, so half of that would be 4. Or essentially, when numbers multiply to 16 and add to 8, or 4 and 4. And over here, I'm just going to kind of clean it up. Now remember, technically we're almost done because we have the x's on one side with a constant and then the quadratic term on the other. But I don't know if you remember me saying that in the hint that your coefficient for the linear term needs to be 1. So I'm just going to really quickly get rid of this negative 2. So here there are 2 terms. So both of them need to be divided by negative 2. But on the left side, it's just one binomial. So that counts as one piece. So I'm going to just divide that whole thing by negative 2. You're not actually going to do anything to the binomial inside the parentheses. You're essentially just pulling out this 1 over negative 2, which is negative a half. Okay, and that leaves you with x plus 4. So this parabola, the major axis would be the x-axis, right, because that's linear term. It would open left because the leading coefficient of the quadratic term is negative, and the vertex would be negative 4, negative 4. Okay, sorry, I kind of like shot out of that view really quick. All right, so essentially, guys, remember you want your quadratic terms on one side and your linear and constant term on the other, but you want to you want to keep the x's together and then the y's together. It really doesn't matter what side you move everything to. So, for example, here I can move these guys to the other side and then complete the square and leave the y plus 18, or I can move the y and the 18 to the other side and leave the 2x squared minus 8x. You could try it both ways and you'll see that you get the same thing. So for this one, my leading coefficient for my linear term is already a 1. So I decided to leave the y and the 18 together. But again, like I said, you can move the constant term to the other side and move the y term to the other side if you want to be consistent with what we were doing over here. Okay, move the constant term over. But again, so maybe let me just show you. You can move the constant term over, and you can move the linear term. for y. And you get 2x squared minus 8x. Or you could have left the y plus 18 and moved the 2x squared to the other side. That would make it negative. And the minus 8x, move it to the other side, would make it positive. So you have choices. I'm going to show you both just so you can see. All right, so here I need to divide out the 2 so that I can complete the square. This would give me x squared minus 4x. Now remember, on the right side, I'm going to need a leading coefficient of 1, so I'm going to have to get rid of that negative 1. Okay, so I'm going to complete the square. So half of negative 4 is negative 2, and negative 2 squared is 4. So technically I've added 8, so I'm going to kind of make up for that on the other side. And this factors to 2 times x minus 2 squared. Remember that half of b is negative, so half of negative 4 is negative 2. And then the last step would be to divide by negative 1 so that the leading coefficient is a 1. So you get negative 2 times x minus 2 quantity squared equals y plus 10. You get the exact same thing if you did it the other way. So factor out the negative 2 in order to complete the squared. So negative 2 divided by negative 2 gives you that positive 1 you need. And then 8 divided by negative 2 would give you negative 4. And complete the square. So this is a negative 8, so I would also do the balance there. And you see you get the same answer. So again, as long as your y's are on one side with a constant and then your x's are on the other, like in this case, right, then you're good. Just really doesn't matter what side you move them to. But the quadratic term is the one you're completing the square for. Okay, so this one, they kind of already have the linear term of x with a constant on one side, and then we have the quadratic. So the quadratic, I'm going to need to complete the square for. So half of negative 12 is 6, or sorry, positive 12 is 6, and then 6 times 6 is 36. Then we're going to maintain the balance, factor this, or just take half of 12 and put it in the parentheses as a quantity squared. And then don't forget that you need your coefficient of your linear term to be positive 1. So essentially, right, you're just, on the left side, you're doing 1 divided by negative 1. Gives you negative 1. Okay, so just remember that you can always rewatch the video, pause, rewind, fast forward if you need some clarification, okay? Have a good day.